Hi everyone, Miss Nelson here, and today we're gonna continue on with Unit 8. We are on day 10, can you believe it? Um, so, to start, our objective for today is how can you interpret weather maps? For our do now, take a look at the weather map below. Where have you seen a weather map like this before, if you have? And then also, what do the symbols represent? Specifically, I want you to focus on the 5 yellow boxes that I've outlined below. What do the symbols in each of those yellow boxes represent? I'm going to give you guys a couple minutes to see if you can figure out what each of those symbols mean, and then we'll check back in. Good luck! Alright, so you guys might have seen a weather map like this on the news sometime, and hopefully by the end of today, you will be able to interpret every component of this map and more importantly, know what that means for the weather in Yonkers or wherever you are. So to start, in boxes 1 and 2, we have an H and an L. The H represents a high pressure system. We've talked about that before. And number 2 represents a low pressure system. As you may remember, a high pressure system represents sunny, good weather, not a lot of clouds. A low pressure system tends to represent storms. To know what's in boxes 3, 4, and 5, you're going to need your earth science reference table, and specifically the section that says front. So if we look at that section, we can see that number 3 is a cold front, number 4 is a warm front, and number 5 is a stationary front. This tells us the boundary between two air masses and what type of air mass is moving where. So, weather maps are used to show the current state of the atmosphere and to forecast future conditions. So what does that mean for Yonkers? What does this map tell us about weather in Yonkers? Well, to start, Yonkers is right here where that smiley face is. If we look at that map, we can see that the cold front is coming in our direction because all those little triangles are pointing towards us. That means that the cold air is coming in that direction. We also know that in the northern hemisphere, air tends to move from west to east, so that low pressure front also will be coming towards us. So that means that we're about to get hit with a cold front and a low pressure system, which means that we can expect colder weather and stormy weather coming our way. Sometimes, though, weather maps look like the one below. Not only do we have the high and low pressure in some fronts, but we have those white squiggly lines. Now, one of you might say, wait a second, this looks like the topographic maps that we looked at the beginning of the year. And to you, I would say, yeah, they're very similar. In fact, both of them are made of isolines. Isolines connect points of equal measurement. But where in our topographic maps we had contour lines that matched points of equal elevation, in this unit we're going to look at isotherms, which connect points of equal temperature, and isobars, which connect points of equal pressure. This is some of our key vocabulary for this unit. So first, let's look at isotherms. Isotherms connect points of equal temperature. So every point along this line will have the exact same temperature. Isotherms generally run horizontally. That's because in northern latitudes, we typically have colder weather, where in southern latitudes, we typically have warmer weather. Isobars, on the other hand, tend to make circles. So here we can see a bunch of isobars, those black lines, that go around circles around either the high pressure system or the low pressure system. As we may remember, wind will go from high pressure to low pressure. Speaking of pressure, isobars allow us to see the pressure gradient. The pressure gradient is the rate of change in air pressure. So let's imagine that we want to find the pressure gradient between A and B. How would I do that? Well, finding the pressure gradient between A and B was a lot like finding the gradient in elevations that we learned how to do in the first unit. First, we need our equation for gradient. Gradient is the change in field value over distance. Remember, you can find this on the first page of your reference table in the box that says equations. So if I write that down, G is going to represent gradient, FV is going to represent the change in field value, and D is going to represent the distance. First, I need to find the change in field value. So what is the field value of A? Well, to find that, I have to follow the line to where I see the value. The field value for A is 1,016 millibars. The field value for B is going to be 1,028 millibars. So the change in field value is the difference between those two numbers. In this case, 1,028 minus 1,016 millibars. To find the distance between A and B, I would have to get a scrap piece of paper, mark the distance between A and B, and then bring that line down into my map scale. In this case, the distance between A and B is about 50 miles. So, now if I calculate that out, 1,028 minus 1,016 is 12 millibars over my 50 miles. If I punch that in my calculator, I'm going to get 0.24 millibars per mile. That is my pressure gradient. what we find is that the closer the isobars, the closer those lines are together, the greater the pressure gradient. That's because we have changes in numbers over a smaller distance. And we know that the greater the pressure gradient, the greater the wind speed. So now, knowing that, I want you to look at this map and label where it would be calm and where it would be windy. So when the isobars are close together, remember that's when we have the high pressure gradient or the fast wind speeds. So where those lines are really close together, it's going to be really windy. Where the isobars are far apart, we have the small pressure gradient, and so slow wind speeds. So if we look at our map, the place where the lines are the farthest apart is right there. And that's where it's going to be calm, or where we're going to have not that much wind. Go ahead and label your map where it's windy and where it is calm. Lastly, I want you to mark your map the way that the wind blows. Remember, wind blows from high to low pressure. So we have a high pressure system sort of near the center of our map, and it's going to go out towards those low pressure systems or away from the high pressure system. We also need to remember though that wind doesn't go straight. It's going to spin. And the direction it's going to spin depends on whether it's a high pressure system or a low pressure system. Remember, clocks are high and counters are low. So because this is coming out from a high pressure system, it's going to go, the line should spin slightly clockwise. All right, this brings me to our exit ticket. There are 2 questions. The first question is that I want you to draw isotherms for 10 degrees Celsius, 15 degrees Celsius, 20 degrees Celsius, and 25 degrees Celsius. You can either take a screenshot of this video and draw on a screen, or you can, on a separate piece of paper, copy down this exact same table. All you have to do is do 6 dots going from left to right and 5 dots going down in a grid, label them, and put a box around it, and you have the exact same chart that I have below. So I'm going to show you how to do the 10 degrees Celsius isotherm in case some of you have forgotten from the beginning of the year. But then you're going to have to do the 10 degrees Celsius one with me, but then also do the 15, 20, and 25. So let's remember, how do we draw isolines? So if I'm drawing an isotherm for 10 degrees Celsius, the first thing I need to do is find the tens. They are right there. But as you may remember, there exists invisible tens in this chart. So for example, between 9 and 11, there is a 10. Between 9 and 13, there is a 10. Between 9 and 15, the number 10 exists. And between 8 and 14, the number 10 exists. So go ahead and put down those tens as well. And then lastly, you need to draw a line connecting those tens and make sure that line either connects to the edge of the map, in this case the square, or connects back in a circle. So go ahead and draw the lines for 15, 20, and 25 in addition to the line for 10 that we just drew. The second question is this multiple choice question below. Take a look at the map. which represents an air pressure field at Earth's surface. And I want you to tell me at which position is the wind speed the lowest. Please remember to send a picture of your notes and the answers to the exit ticket, both question 1 and question 2, to Ms. LaPlaca on Remind. We're going to be entering those grades, and we are keeping track of who is participating, who is not, and hopefully we can give you some feedback to make sure that you are on the right path. All right, I hope you guys are all safe and happy. And as a reminder, I'm going to be sending out presentations now every other day in the hopes that I can hopefully give you guys some more feedback. It gives me more time to create these presentations and more time for you to complete them. And I hope you guys are well. I miss you a lot. All right, bye.